Welcome to the second part of our Cauchy-Schwarz masterclass. Today we want to talk about an interesting trick that is very often used, which is called the one trick and the splitting trick. So let's take a look at it. So, oops, and let me now delete this. Just okay. It's called the one. Oops. It's called the one trick and the splitting trick. So we have two inequalities that we want to use. Let's start out with the one trick. So this is basically the following inequality. We have 1 plus a1 plus a2 till an. We have n real numbers, which is smaller or equal to the square root of n times a1 squared plus a2 squared, and so forth, till an squared. Okay, why is this true? We want to remember the Cauchy-Schwarz Cauchy-Schwarz inequality, which says that a1 times a2 plus no, let's write this. That's not a1. That's b1, and then a2 times b2, and so forth till an bn. This is smaller or equal to the square root of the sum of all the ai squared, 1 to n. Actually, we could have written this the left-hand side as with the sum formula as well. But anyways, sum from 1 to n, which is of bi squared. Okay, so this is basically the Cauchy-Schwarz inequality. So how can we see that from this immediately the one trick follows? Well, basically we have here a 1 times a1 and a 1 times a2 and so forth. So let's write this out. So we have the summation of 1 times a1 from 1 to n. This is smaller or equal to the square root of the first. We want to look for our ai squared. In our case, that's the summation of from 1 to n of all these ones squared, of course, but it doesn't matter if 1 squared is equal to 1 times the square root of. Oh, actually, that's a very interesting. I missed the square root here. Yeah. Okay, now the summation of ai squared from 1 to n. Well, this is exactly the square root of n times the square root of the summation of ai squared from 1 to n, thus proving the inequality. Of course, we just wrote this one for to make the point clear of how we use the Cauchy-Schwarz inequality, but this is basically the one trick. Now let's move to the splitting trick. Okay, so here we have the summation of ak from 1 to n, smaller or equal to the square root of the summation of from 1 to n of ak to the power of 2 over 3. We're going to understand this a bit more why this is, times the square root of the summation from 1 to n of ak to the power of 4 over 3. Okay, how do we prove this? Let's start out with the left-hand side, which is from 1 to n, ak, which is equal to the summation. And here is now where the name of this trick comes from. We are going to split this ak into two parts. The first one will be ak times 1 over 3 times ak times 2 over 3. Well, and this is basically now we're going to use the Cauchy-Schwarz inequality. That's basically our ak, and that's the bk of the inequality that we wrote above. This is smaller or equal to the square root of the summation of this first thing to the power of 2. We want to square it, and if we square it, well, we get then 2 over 3 times the square root of the sum from 1 to n, ak to the power of 2 over 3. We have to square now the second part, which is this, which squared will be ak to the power of 2 over 3. and this proves our splitting trick. Okay, so what did we do? We introduced the one trick where we use where we have the summation of n real numbers, and we estimate it by the square root of n and the square root of this of the sum of the square of these real numbers. And the second part was the splitting trick, where we splitted our sequence numbers such a way that we can do an estimate. Yeah, so these two tricks will be used in the future, so that's why we introduced them. And yeah, that's it for today.